so integration in this form. All right, so we talked about some formula before. All right, so we're going to talk a bit about more formula. All right, which if you look at this, this is quite unique kind of situation that we find ourselves in. When you want to integrate a fraction whereby the numerator is a constant and the denominator is a quadratic. Right, now bear in mind, the denominator is a quadratic, can come in different forms. So this is a non-factorizable quadratic. All right, as you can see, this is a factorizable quadratic, this is also factorizable quadratic, okay, but they're all quadratic denominator, okay. So basically, this yellow part is all given in the formula list. All right, so you probably go like, oh, actually quite easy, right? You are absolutely right. It's quite easy. Just follow the formula. You can't go too far wrong. All right, so this is tangent inverse. You probably is quite familiar with this because you learned the differentiation version, okay? Except that differentiation, you don't really care about the 1/a thing, right? But yeah, that's the integration version. All right, so this one, okay, you probably learned it another way also. I'm not too sure. This is a formula-based question, but you could have done it yourself because you can actually prove this quite easily because this is factorizable. And when it is factorizable, you can change it to partial fractions. Okay? And when you change it to partial fractions, you can integrate, which you will get ln something minus ln something, and that's how it becomes like this. Okay, can? All right, so in short, this is doable for Sec 4 kids. Okay? Sec 4 kids can do this because they can integrate 1/x plus a1. Right? They can integrate the ln thing. Same thing here. As long as this is integratable, factorizable, okay? Then it is doable by partial fractions. But you obviously don't want to waste time doing partial fractions when you have the formula, right? Yep. And that is what we should be looking at, okay? Now, one thing that's very, very important about this, okay, is that actually two things, right? One is that you don't expect the question to throw in your face like this, okay? Like, oh, like this, you wish, right? So for example, my take on this is that you are not expecting a question like this. I mean, come on. How many marks do you think they'll give you this, right? So this is like applying formula. So you go like, oh, x is x, a is 2. So you go like, well, that's super easy. Tangent inverse x/2, and we are done. So you think they give you marks for this? No, you wish. Okay, so it won't happen, right? So it's too easy. So what I want you to be aware of is that sometimes you're faced with situations like, let me be a bit, why the questions all so hard? Okay, anyway, so let me show you the formula first one time, and I don't want to one shot go into something so hard, okay? So I want to highlight to you this problem with this formula. And you better know it, because even J2s, right, they tend to make this kind of careless mistakes. I call it careless mistake because it's actually quite simple. All right, so you go like, Mr. Ang, very easy. Okay, now let me show you one question. Okay, so let's imagine we have this 9 plus 4x squared dx. Okay, how do we do this? They say, okay, Mr. Ang, that's quite easy. Duh. A is 3. I can see that. A is 3. X is 2x. So if I follow the formula, I'll have 1/3 tangent inverse to 2x over 3 plus c. Ta-da! I follow the formula. I can't go wrong. Wrong. Okay, and you better know why. This is very, very important. All right, now in your formula list, you have the formula list has one problem. Okay, it is what we call chain rule deficiency. All right, they totally don't have any chain rule problem. Why? Because in the formula list, their x is forever 1x. Understand? So when they have 1x, obviously then 1x, there's no chain rule problem, right? Like we all understand that when we differentiate sine 2x, the 2x, the 2, you have a chain rule issue, right? Because later on we need to multiply by 2. In the formula list, when they have shown us the formula, or even the differentiation version, the integration version, right? When you want to use the formula list, you want to be aware that their x is forever 1x in the formula list. In reality, our x may not be 1x. In fact, in reality, our x is never 1x. Understand? So this is wrong. Because when you differentiate this, your x is 2x. You have an extra 2 somewhere, which you didn't compensate. Understand? So the correct answer, let me show you. The correct answer should be half of this. Half. Understand? Now you better know where the half come from. Come from the coefficient of x, 2. Because when you differentiate, you multiply by 2 extra. So when you integrate, you get rid of the half. Get rid of the 2. Right? Understand what I'm talking about? Now this is a very, very common error for many students. The good ones included. Okay, good students, like, they're always very good. Everything also get A. But this one, they blur. Okay, because it's so tempting, right? Just follow what. Understand? But it's wrong. So there are 2 ways to go about doing this, or go about overcoming this issue. First is to know it very, very well, which I hope you are now, right? I keep telling you this, right? There's no chain rule, there's no chain rule, there's no chain rule. Okay? But in real life, there's always chain rule, there's always chain rule, there's always chain rule. So you want to be aware, right? So once you're aware, then go like, okay, I just need to compensate. Okay? But this strategy may not work so well, because during exam, people get a little bit more panicky, anxious. You forget one. Okay? We'll forget even the best students, right? Not that you forget, you become a lousy student. So there is another way you can handle this, okay? Which I actually much more prefer, because you can make it into a habit, right? And the habit is this, okay? So the formula is up here. I probably want to show it. So let's imagine I want to show you, I want to solve this same problem again, okay? So how am I going to do it? Let's say I have very bad memory, right? I go like, I probably will forget about the half. Yeah. So is there a better way? Yes, pay attention. What I prefer to do is to make sure your x is always 1x. How am I going to do that? Well, factorize out the 1/4. So you factorize out 1/4, you get 9/4 plus x squared dx. Ta-da! Then you go like, so I have a 1/4, but that's okay. A 1/4 is just there, it's a constant. But this, whatever that's left over on the inside, is literally the formula. You really just use the formula word for word, letter for letter, you can't go wrong. Because your x is now 1x, same as the formula. Understand? And you can just apply the formula. Let me show you. Okay? So you have 1/a. What is a? A is 3/2. Okay? So 1/3/2 is 2/3, right? So 2/3, tangent inverse x over 3/2, which is your 2x/3 plus c. All you are giving up is that you have a few more steps, really. Okay? In compensation of being correct all the time. So you actually have the half and the 1/3, which is 1/6, tangent inverse 2x/3 plus c. And that will be the correct answer, as you can see here. Understand? So like I say, you have 2 options to deal with this problem. Okay? One is to make sure you always remember very consciously there's always this chain rule problem. Okay? But that one you have to judge for yourself, because some people can, some people cannot. All right? It doesn't mean you cannot, you're a lousy student, just that you tend to get forgetful about that, right? Okay, so it happens. So if you can remember, awesome. If you cannot remember, forget it. Just make it into a habit, right? Always make sure your x is 1. Then you use the formula as it is, whether you're differentiating or integrating. As long as you're using formula list, you want to pay attention to this. Are we all clear? Okay? So this is important, because a lot of students, a lot of very good students, wasted a lot of marks on this. Okay? Now, let me show you a few more. All right? Now this is a bit harder. Okay? The example is a bit harder. So take a look at this. Again, there's a chain rule issue, right? You can see that? There's a chain rule issue because there's a 2x inside. So this is one way you can do it, like I'll show you. Just remember to have the half, which can be a challenge to some people, because people just forget. Okay, so this one is the way that if you want to do it, okay, fine. Another way, like I showed you earlier on, that's factorize out the 1/4. So you make sure x squared is forever 1x squared. Then this one, you use the formula, then you can't go wrong ever. Are we all clear? All right, now, what if it is a quadratic, but it is not in the neat form like this? You don't expect the quadratic to be always so nice and neat for you, right? So sometimes they give you rubbish like this, and you go, what do you do? Okay? And the trick to do this, in fact, is quite easy. You complete the square. Okay? And you literally complete the square. So it is a bit messy, but probably I show you, then it doesn't look so mysterious. Okay? Because whenever you look at the printed textbooks or notes or what, it always look like, obvious. But when you do, you have a different feel. So let's say I want to solve this. All right, the first thing you want to recognize is the upstairs is a constant. All right, the downstairs is a quadratic. So you know it's a formula-based kind of thing, because I told you, right, the formula says 1 over a quadratic denominator. So you just want to look out for the quadratic denominator, you're done. Okay? So quadratic denominator, okay, confirm is a formula, but I just don't know which version. So what do? You complete the square. So in order to complete a square, you're going to make sure x squared is 1, right? Why do I come up with questions like this? Make my life hard, seriously, 1 by 9. Anyway, make the x squared 1, then you complete the square. Assumption is everybody knows how to complete the square, right? So it's x squared minus away divided by 2, so that's divided by 2 is 3 over 6, so 3 over 9, sorry, 1/3. Square, then you minus the 1 over 9 plus 5 over 9, okay? Again, assumption is all of us know how to do, shouldn't have a square anymore. Just make it worse. Hold on, let me just get rid of this, okay. All right, so we have x minus 1/3 square. This is 4 over 9, right? Positive 4 over 9, okay? So which version is this? This is the x squared plus a squared version. It's non-factorizable. Okay, so we are looking at which one? This one, tangent inverse. Understand? So it's x squared minus something that is a ln, right? A minus something is another ln. Okay, so but the whole idea is quadratic. Get the idea? You recognize it being quadratic, then you go figure out which version. Understand? How do you figure out? You do complete the square. Then now it's obvious. This is the non-factorizable one. This is the tangent inverse one. The good thing about complete the square is you've done all the hard part in the beginning. So your x is forever 1x. Right? So you don't have a chain rule issue. So this is literally your x. This is literally your a square. So if you follow the formula, I hope you can remember, but it's in the formula list, right? You will get 1 over 9, 1 over a. What's a? A is 2 over 3. Correct? A is 2 over 3. 1 over 2 over 3 becomes 3 over 2. Tangent inverse x over a. It looks a bit nasty, but it is literally following the formula. All right? 1 over a, tangent inverse x over a. Are you all following? So you will encounter situations like this or like this. But what is important is you are clear. Oh, this is a quadratic denominator. All I need to figure out is which version of the formula I'm using. Understand? How do I figure out? I complete a square. I mean, this is obvious because you don't have to complete a square for this, right? I mean, this is obvious because it's there, this one. Agree? So you just follow. But then again, there's a chain rule issue again. So you want to be clear about the chain rule issue. So you either factorize out the 1/9 or you just remember to divide by 1/3. I mean, divide by 3. Okay, get the idea now, guys? Can? Okay. So this is the first set of formula you want to get used to, right? So sometimes after you complete a square, you end up with a minus. That is the ln version. You follow? That's all. Okay. So it's formula based. I would say rather easy. Okay. The other one is this one. Okay. Now this one is the sine inverse formula. Again, the structure looks very much like this, but what is important you want to pay attention to is it's a fraction with a quadratic denominator but as a square root sign. Okay, with a square root at the denominator. Alright, now there are not many formula to help us do this. In fact, this is one of them, and the other one, we talked about it not too long ago, is the cousin. Remember this? So which is why the cousin turns out to be actually quite important for you to see a couple of times and remember, because whenever you see an integral that you want to solve, right, you want to integrate something which is a fraction, but with a square root denominator. These are the only two friends you have. Okay? And look out for the difference, please. Constant numerator, non-constant. Immediately you know which version to be thinking of and which version to do. Understand what I'm talking about? Okay, so basically you see a square root at the bottom, you don't have many friends already. Only these two. Right? And it better be quadratic, but this one doesn't have to be quadratic. Okay? So you have to, you have to be familiar lah. What I meant is you have to be familiar. Because when see this question, what do you think of? You get what I mean? What do you think of as like, is it the cousin? No, it can't be. Because if you want to differentiate the inside, it can't be a constant. Right? Cousin has to be the f prime. Okay? So you have to know things quite well. Alright? So similarly, this formula is given in the formula list. Right? It also has the same problem of what we call chain rule efficiency. Right? There's no chain rule. The x is forever 1. Okay? So if the x happen to be not 1x, then you better justify. Okay? Not justify, compensate. You want to be careful with that. Are we all clear? Alright? So let me show you a quick example on how to do that. I is this part D. Let me see which one I copied. Okay, now this one. All right, how do we integrate this? Okay, we first thing, okay, there's a square root sign. Okay, so I have two formula in my mind, the cousin and the sine inverse. So I know my cousin quite well. So I say that, hey, in order to be the cousin, upstairs has to be the f prime, which you know is impossible. So you can forget about cousin, right? Then you start thinking of the sine inverse. So sine inverse formula looks like this. Let me write it down one time for you to see. So it looks like this, a square minus x square. Take note, it's a square minus x square. If it were to be the other way around, it doesn't work. Means we're in trouble anyway. Okay, so that'll be a substitution question. Anyway, so we have this. The good thing about the sine inverse is a bit easier than the tangent inverse because they don't have the 1 over a rubbish. But still, the chain rule problem. Okay, so how do we do this? Well, the first thing you have to do is to try to get to that form. How do I get to that form? You guessed it. Complete the square. That's the only thing you can do. Okay, so let's try. Okay. Now the complete square is not going to be pretty because it's going to be quite stuck in this big square root rubbish, right? So it's this rubbish here that I'm trying to complete the square. So again, the rules that you learned in Sec 3 applies until today. Okay, which is factorize out the negative. Okay, and then you start to do your complete the square. All right, so the complete square looks a bit like this. Now, there's a negative inside. Please don't take it out. It's inside the square root. Okay, you cannot square root negative yet. Next year you can. Okay, but you also won't want to do it. Trust me. You just leave it inside. Okay. So complete the square for this is easy. This is x plus half square, and then minus 1/4 minus 4. Okay, and then you have this 1 over square root. This is actually 5 over 4 negative, yeah? Correct, no, not 5 over 4, what am I talking about? 17 over 4, right? Yeah. 17 over 4 negative. But when you multiply the negative, it becomes positive. And then multiplying the negative, it becomes negative here. And it better be this, because you want the x to be negative. Understand? If somehow it swap place, you must be certain that you must be quite clear that it must be my complete square that's wrong. Understand? Because if the question gives you the other way around, I'm so sorry you can't solve it this way. It's not using that formula anymore, right? It's using something else, probably by substitution. Okay, are we all clear? But anyway, the substitution is another beast altogether. But my point is there's a way for you to check. It serves as a checking mechanism. So when you complete a square, the good news is the x is always 1x. So the a is there, the blah, 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 you get the answer almost instantaneously, right? So you get tangent inverse, x plus half over square root 17 over 2 plus c. That's your x over a. Simplify, of course, but that's it. Understand what I'm talking about? So we're talking about one thing that's actually quite easy, because we're just talking about applying formula. Okay, but just the easy act of applying formula, you will see that it's not so simple anyway. Students can still get wrong even the formula is right in front of them. Okay, that's because they are not familiar or they are not aware of the chain rule problem. Okay, so where's the question that I just did? Yeah, this is the one, right? Okay, whatever. So you can see that it becomes more complicated, but the idea is the same. Okay, so this one, okay, can't say we don't do anything. I tell you what, I just want you to do one question and then we'll move on from there, okay? So let's try to do part V, shall we? Yeah, V will be good, okay? V, quickly.